Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Widya Sukma Hasanti. In this video, I will tell you about the map of physics. Physics is a hard subject that covers many different topics going from galaxies in the depths of space right down to subatomic particles. And if you don't already know, physics is difficult sometimes to see how all these different subjects are related to each other. So, this is the map of physics. I hope you enjoyed. Physics can be broadly broken down into three main parts: classical physics, quantum physics, and relativity. We'll start with classical physics, and a good person to start with is Isaac Newton. His laws of motion describe how everything made of matter moves about, and his laws of universal gravitation tie together the motion of planets in the sky with the falling of objects on Earth into one elegant and general description. He also invented calculus, a supremely powerful mathematical tool which has been used over the centuries to derive new physics. Newton also made strides in the field of optics, which is the physics of light and how it travels through different materials. Optics is closely related to the theory of waves, which is basically how energy can travel through disturbance of a medium, like ripples on the surface of a pond or sound through the air. Light doesn't need a medium to travel through. It can travel through the vacuum of space, but it still follows the same principle as always, namely reflection, refraction, and diffraction. This leads us to electromagnetism, the description of magnets, electricity, or more generally, electric and magnetic fields. It was a physicist called James Clerk Maxwell who discovered that these are two aspects of the same thing and derived the wonderfully elegant rules of electromagnetism, and the theory realized that light was an electromagnetic wave. Electromagnetism also explains all of electricity. Jumping back a little bit, classical mechanics is related to Newton's laws and covers the properties and motion of solid objects. How they move when force hit them, what happens when they are joined together, like in gears or buildings or bridges. Fluid mechanics is the description of the flow of liquids and gases. Using fluid, you can work out how much lift is generated from an aeroplane's wing or how aerodynamic a car is. So, this is all of classical physics, the picture of the universe we had around the year 1900. However, not everything was solved. There were just a few of holes in experiments that hint at something more. Physicists at the time thought that they would solve and explain these problems. Soon enough, but poking at them, they unraveled the new dominance of relativity and quantum physics and turned our understanding of the universe completely on its head. Albert Einstein was the genius who developed the theories of special and general relativity. Special relativity predicts that the speed of light is constant for all observed, which means that when you travel really fast, rates to start happening like time slowing down. It also states that energy and matter are different aspects of the same thing through the famous formula E equal mc squared. General relativity says that space and time are part of the same fabric called space-time, and that the force of gravity comes from objects bending space-time, making other objects fall in towards them. While relativity described the very big, other physicists were busy at work on the very small in the world of quantum physics. Atomic theory proved that nature of the atom and more detailed description of the atom were developed. from a tiny sphere to electron orbits to energy levels and then to electrons being wave-like charge distribution. Nuclear physics describe how the nucleus of atom behave and explain radiation. Nuclear fission, the splitting of the atom used in our nuclear power plants, and nuclear fusion, which takes place in the sun and will hopefully soon be harnessed here on Earth. Particle physics probes even deeper to find the fundamental subatomic particles that everything is made of and are described in the standard model of particle physics. Quantum field theory captures all of quantum physics and combines it with the special theory of relativity and is the best description of the universe we have. Unfortunately, quantum field theory doesn't include gravity, and so physicists don't know how to join together quantum physics and the general theory of relativity, leading the giant chasm of ignorance. So, that's all for me. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.